Okay, here's number 10 on the chapter 3 review. On this one, we need to just describe the transformations that are being applied to the function of f to obtain g. So we're starting out with the absolute value of x. So we have to look to see how does that function change going over here where we've got a negative number out in front, the 2 in front of the x, the minus 9, and the plus 5. Okay? The negative out in front affects the vertical, anything on the outside of absolute value is a vertical transformation. The negative out in front means that you are affecting this as a reflection across the x-axis. So that negative right there is a reflection across the x-axis. Okay? That 2 on the inside, and remember, anything on the inside is opposite of what you see. So that 2 on the inside means that you are shrinking this function in a horizontal manner. So we are horizontally shrinking. And on the inside with that number, we always take the reciprocal. And so the reciprocal of 2 is 1/2. So we're horizontally shrinking by 1/2. The minus 9 right there is shifting either left or right. And because it's the opposite, we look at it as a positive 9, which would be to the right. So right, shifting right by 9 units. And then this 5 on the outside is straightforward. It's up or down because it's plus 5. It's going to be up 5 units. And that's what we need to write to describe all those transformations. All right, let's look at number 11. This is the graph of f is given to us, and we want to graph the function when we have this 2 out in front, which vertically stretches by 2. That means all of our y values are going to be multiplied by 2. The negative on the inside horizontally reflects. So this reflects across the y-axis because sideways goes across the y-axis. And then this plus 2 out here is shifting up 2 units. So I need to do all 3 of these things to my graph. I'm going to start with the vertical stretching by a factor of 2. So in the middle, that's 0. I can't multiply 0. Well, 0 times 2 is still 0, so that doesn't change. At this point right here, that's my y value is 1. So if I'm doubling that, I'm going to have a new y value at 2. So the 0 stays at 0 because you can't, if you multiply by 2 times 0, it's still 0. The second point goes from 1 times 2 to get 2. And if I go across the line here, I'm staying at the same value all the way to where x equals 3. So I'm going to do the same thing on when I'm vertically stretching. So all those values on the blue line, the y values are all 1. So you double those, so all the values are 2, which is reflected or shown with the red line. And if I go along to the end of my graph at 1, 2, 3, 4, 5, 6, 7, 8, where x equals 8, my y value is 4. right there, my y value is 4. So if I double the value of 4, that is 8. And so my new point is going to be up here at 8. Okay, so that done is done, and we're going to move on to the reflection across the y-axis. So in green, I will do the reflection across the y-axis. Well, a reflection means you're going to see a symmetrical graph. So my first point at 0, 0 is not going to change. My second point, which is at 1, 2, is going to go to the opposite side and be at negative 1, positive 2. And at the end of that straight line there, the horizontal line on the red, that's at 3 comma 2. So I'm going to go to negative 3 comma 2 and draw my point. And then the other point, the end point over there is at 8, negative 8. So, or I'm sorry, 8, positive 8. So I'm going to go negative 8 and positive 8 and reflect across the y-axis. So this green graph shows the reflection across the y-axis. So I'm done now with that. Okay, and I'm going to do in purple. So I thought it was going to be purple. Oh well. I guess in black, I will graph now, shifting my graph up by 2 units. So each of these 4 points that I've been focused on, I'm going to move them up by 2 units. So my 0, 0 is now at 0, 2. My negative 1, 2 is now at negative 1, 4. My negative 3, 2 is going to be now at negative 3, 4. And my negative 8, positive 8 is now going to be at negative 8, positive 10. So I'm just moving all of those points up by 2 units. And we need to make sure that somehow we identify what our final outcome is when we are showing anything like this on the test. And so if I can personally erase this. On the test, you can draw very light lines when you are in the process of transforming your function, and then do a really dark one for your final answer. And that would be it. For number 12, this says a function of f is given and the transformations are given. We want to write the new equation of f. Well, f is x squared. So essentially what I want to do is I want to set this up and give myself some space to put these values. I might need to put something out in front. I might need to add or subtract something on the inside. I actually might need to put something in front of my x, and I might need to add or subtract something afterwards. Okay, so I need to accommodate for all of these in all these 4 locations, the A, B, C, and D on our notes. A shift to the left by 3 units means on the inside of the function, meaning inside of the parentheses, I need a plus 3 because a plus 3 shows us a shift to the left by 3. To shrink vertically, that's going to be on the outside. That's going to be in that A position. So stretching and shrinking vertically is that first value, and it's 1/4. So I'm going to put 1/4 out there for that shrinking vertically. And then I have a shift upward of 6 units. So that's out here after the function. So my final answer is 1/4 times x plus 3 in parentheses squared plus 6. And that shows all the transformations that were explained to me. Okay, let's look at number 13. Here we have 2 functions. We have f and we have g. We need to show f plus g. So we are going to take these 2 expressions and just add them together. So when we are adding these together, we are just combining like terms. We have 3x plus 4x. That gives us 7x. We also have 8 minus 4. So that's going to give us plus 4. So f plus g is simply 7x plus 4. To find the domain, we need to look at the domain of each of the original expressions and then put that together. If we start out with the 3x plus 8, the domain there is all real numbers, so from negative infinity to positive infinity. And actually, same thing with 4x minus 4. We are going to use all real numbers. So when we look at that and we look at our final expression, there are no limitations anywhere in any of this. So our final domain is still going to be all real numbers. When we look at f minus g, we are going to take those same two expressions. But when we subtract, the second expression needs to go into parentheses. And you're going to distribute that subtraction, and you will get 3x plus 8 minus 4x plus the 4. And then combine like terms. So we have 3x minus 4x, which would be negative x. And then 8 plus 4 is 12. And so f minus g is equal to negative x plus 12. Again, for the domain, both of the initial expressions are all real numbers, and there's no restriction in our function here, so our domain is simply all real numbers. When we do f times g, we have our 3x plus 8, and because it's an expression, a binomial, we have to put it in parentheses times the 4x plus 4. And here we just do the FOIL method, distribution of terms, whatever. So 3x times 3x is 12x squared. 3x times 4 is 12x. We have 8 times 4x, which is 32x. And then we have 8 times 4, which is, oh, I see. I'm sorry, I messed that up. It's 4x minus 4. So 3x plus 8 times 4x minus 4. So 3x times 4x is 12x squared. 3x times negative 4 is negative 12x. 8 times the 4x is plus 32x. And 8 times negative 4 is negative 32. So we have these like terms here in the middle. So we're going to get 12x squared plus 20x minus 32. And so f times g is equal to that. We cannot do anything more with that. We don't want to factor anything out or anything like that. We're done. So again, there's no restrictions from the original two functions. There's no restrictions from this. Our domain is going to be all real numbers. Now when we look at f over g, that's going to create 3x plus 8 over 4x minus 4. We cannot simplify that any further, so that is just our answer right there. Now when we consider the fact that the initial two functions have all real numbers, but in our answer here, 4x minus 4 is in the denominator of the function. So what we need to do is we need to take 4x minus 4, set it not equal to 0, and we need to solve. So we add 4, we get 4x cannot equal 4. We would divide by 4 and get x cannot equal 1. So we consider all real numbers except for the value of 1. And so we write that by going negative infinity to positive 1, and then a union, and then we start back at 1 and go to infinity. So that allows us, with the parentheses at 1, that is showing that you do not include the 1. So that's how you're skipping over the value of 1. Okay, let's look at number 14. Number 14 does the composition of functions. That means f of g. Okay, and what that means is we're going to take the value of g, whatever the expression is on the g, and we're going to plug it into the expression for f. Just like if we had f of 2, you would take this 2 and you would plug it in for x and get 3 times 2 plus 8. Well, instead of a number, we are plugging in the expression of 1 over x. So we put in the 1 over x in for the x when we are talking about the f function. And we then simplify that to be 3 over x plus 8. And that would be f of g. For g of f, that's taking the function of f and plugging it in for g. So we have our f function, which is 3x plus 8, and we're going to replace the x in the g function. So instead of 1 over x, it's going to be 1 over 3x plus 8. And that's all we can do. There's nothing else we can do with that. For f of f, we're going to take the function of f and plug it into itself. So the function of f is 3x minus 8. So instead of the x, we're going to put in 3x minus 8 plus 8. So we have, if you kind of look at this, we have this 3x minus 8 in place of the x, where we had originally 3x plus 8. We put in 3x minus 8. So we distribute the 3. That gives us 9x minus 24, and then plus the 8, and we get 9x minus 16. And that's our answer for f of f. And then for g of g, we're going to take the g function and plug it into itself. And so instead of 1 over x, it's 1 over x. So the 1 over x right here replaces the x from the initial, function. So 1 over x. Now because that's a complex fraction, we need to multiply that by the reciprocal. So 1 times x over 1. And then we simplify that. 1 times x over 1 is just simply x. So g of g is equal to x. Looking at number 15, we have, this is supposed to be an f there. So we have f of x equals 1 over x minus 1. We have g of x equals x over x minus 1. And we want to do f divided by g. And then simplify. We also need to state the domain. So we're taking the function of f. We're putting that in the numerator. We take the function of g and we put that in the denominator. Well, just like on number 14, if you have a complex fraction, you're going to multiply by the reciprocal. So you take the top and you leave it as is, but you take the bottom and you're going to do the reciprocal. So x minus 1 over x. When you multiply fractions, you can look to see if you can simplify before you multiply. And the x minus 1 is on top and on the bottom, so we can cancel that out. And we're left with 1 over x for our final answer. As far as considering the domain, we need to consider the original functions where x minus 1 cannot equal 0, which means x cannot equal 1. Let me see if I can move this stuff down. Whoa, not that part. Okay, there we go. So with the f of x, we know that x cannot equal 1. Well, same with g of x. It's still x minus 1, so we know that x cannot equal 1. In my final answer, we have x in the denominator, which means x cannot equal 0. So between all of our options here, we know that x cannot equal 1 and x cannot equal 0. So as far as interval notation goes, we're going to go from negative infinity to 0, and then we'll skip over the 0. We can go all the way to 1, but we have to skip over 1, and then we go from 1 to infinity. Okay, so that allows us right here to skip over 0, and then we include values like 1/4, 1/3, 1/2, all those values in between 0 and 1. But then we skip over the value of 1, and then we continue on to positive infinity. Okay? So this is the domain, and this was our answer simplified. And finally, number 16 and 17. Here we are adding these functions using these graphs. So it's graphically graphic addition. Okay, graphic addition. And we are simply adding the y values, oops, adding the y values from f to g, or g to f. I always go with the graph that's on the top, and I add it to the graph that's on the bottom. But I look at the, if there's like a graph like f here, where there's different directions in the graph, where g, it's all one direction, it's a straight line, and everything like that. I'm going to take these points on G, and I'm going to figure out those values of Y. For example, right there is like negative 3.75. Okay? Or, well, I'm sorry. Actually, what I'm going to do is understand that that x value is at 0. Over here, my x value is at 1, 2, 3, 4, 5. So I'm going to locate the value of y on the graph of g at these particular points that I have identified from f, the different x values. And I look to see, okay, that point right there is 1 unit up. So my y value equals 1. So I want to add 1 from my f graph to create a new point. I will graph it in red. Okay, so I moved up by 1. The second point here is 1, 2, 3.5 units. So y equals 3.5. So I'm going to go down to the f function, and I'm going to add 3.5. So if I add 3.5, I go 1, 2, 3.5, which is right there. And then I go to the last point, and that's 1, 2, 3, 4, 6 at y equals 6. So right there, I'm going to add 6. And if I add 6, I go up 1, 2, 3, 4, 5, 6, and that point is right there. And then I just connect the dots, and that is f plus g. So f plus g. And looking at number 17, same kind of thing. I look at the graph that has all the different points and everything, which would be f, okay, and I'm going to locate the points and identify those values of x. So I have right there at -5, here at -3, here at 1, here at 4, and over here at like 8 or 9. 9, I guess. Okay? And I want to identify those points on my, well, okay, since my f graph is on the top, I'm going to identify y equals 2, and at that point down on the g, I'm going to add 2 units. So if I add 2 units, I'm going to have a point like right there. When I go over to the second line from the left, my y value is 1, 2, 3, 4, 5, 6, 7. Okay, and so down on the graph of G, I'm going to add 7. So let's see, 1, 2, 3, 4, 5, 6, 7. That's right there. When I go over to the third mark, that y value is 1, 2, 3, 4, 5. So right here, y equals 5. So I'm going to go down to the G graph and I'm going to add 5. So 1, 2, 3, 4, 5. That's like right there. And then on my next graph or point, I'm at y equals 2. Y equals 2. So I'm going to go down to the G graph and I'm going to add 2 units. And that gives me a point right there. And then I go to the last point over here, which is a y value of 3. And I go to my G graph on the line and I'm going to add 3, and which would give me a point like right there. And then I connect the dots. And that right there is my f plus g. And that's it.